Hey guys, so on your four-sided metric ruler assignment, it might have been hard working with your group members, or it might have been difficult to see or hear. So let's go ahead and take a look at that. So the idea or the concept is that you're using your two rules of measuring. The first one is that you cannot go beyond the precision or go one beyond the precision of the instrument. And so for instance, if I was using this graduated cylinder, you'll notice here it's going 1 milliliter at a time. So I can measure or estimate in between the two 1 milliliter lines to get like a 0.5 or a 0.6. On this one, the precision of this instrument is actually much more precise. And so between the 2 and the 3, there are 5 lines. That means each are 2 milliliters. And I can actually measure more precisely doing that. And this is a 10 milliliter graduated cylinder. So, sorry, it's 0.2 of a milliliter. So this is just important, is to know the device that you're using. And so in your four-sided ruler, we're showing you that you can use one device, but the precision can be different. So for this activity, I ask that you pick an item to measure. And so I am going to show you those using those tools, what I did, but I'm going to show it using this piece of tape. So we're going to start with the 1 meter side, okay? And we're going to measure this tape. And the precision of this meter is from this end to that end. So that's the precision. So I have to make an estimate on this one. And so I'm going to say that my estimate is between, well, I think it's a little over 5, but I have no idea if it's closer to 6. So I'm just going to say 6. So I'm going to say that it is 0.6 meters, because we are looking at a meter stick. So 0.6 right? 0.6 meters. Now note, all of these measurements need to be in meters, okay? And so when I go and I use the next one, which is side 2 has these white and orange stripes on them. And that is, if I were to count them, there should be 10 of these. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So there's 10 of these. So that makes this a deca, right? It's in a set of 10. No, sorry, not deca, deci. See, you got to make sure you pay attention to the word. So this is deci. So this is a decimeter, right? There's 10. And so we're going to measure using the decimeter side. So you'll notice my precision would be 1, 2, 3, 4, 5. So my precision is 5, but I'm going to keep this answer in meters. So in meters, okay, 5. And now I'm going to do an estimate. I forgot. If you underline your estimate, that'll help you remember the precision of the instrument. So here I am. I'm looking at this. And 5. And I'm going to go ahead and say that I think that's like 5, 8. So I'm going to estimate an 8. You might estimate a little different than me. That's fine. But the estimate is there. Now, the next one is to use side 3. Side 3 is the orange side. And you'll notice that if I get this orange side up kind of close, I've got 1, 2, 3, 4, and there are lines in between, but that's just showing the halfway point. But this is really showing all the way down here to 99, 100. So 100, and so this is the centimeter side. We're going to go ahead and do the same thing. We're going to measure our piece of tape using the orange side here. And Now my precision is much more, well, it's more precise, right? And I'm getting a little bit of a glare there. Okay, a little bit better. All right, so looking at this, my tape is at 57, but that's centimeters, and I want it in meters, so it's going to be 0.57, and then I can make an estimate. Actually, getting right in line with it, I might actually be 5.6, and then my estimate would be a 9. It's really close there. So I'll show you what that looks like written down. My 6 and 7, I merged it, but that's what it looks like being written down. Okay. So the next side of this meter stick is going to divide it into 1,000. Okay, this side is divided into 1,000. So if I were to count all those tiny little lines, which would take me all day probably because I don't count very well, to 1,000. Okay, it's a lot. So we're going to do our measurement just like we did before. Okay, but this time, just make sure that you're using the precision of the instrument. So to help me use the precision of the instrument, I'm actually going to use the piece of paper that we've been using, and I'm going to put the piece of paper right along the piece of tape. Okay, and I am reading, let me make sure it's lined up over here. Okay, that's right. And I am reading 56.5, which I'm not correctly stating that because this should be in meters, so that would be 0.5650. So 0.5650 meters. And so now you'll see that my precision got better as I used the different sides. So I went from a 6 estimate to a 5650 meters. Now, this was using the millimeter side. Now that you have this top part done, I did do rule 1, which was estimate beyond the precision of the instrument. I made sure I didn't have any naked numbers, and all of these are in meters. So make sure you've done that. If your group didn't, you can always convert them back into meters. And then answer the following questions, right? You could answer all of these. And I'm just going to bring us back one more time to our graduated cylinders to just think about this. Think about the precision you're using and what you need to measure. If your experiment is calling for 100 milliliters, then this would be probably a good device to use. Probably not so great because you'd have to fill this up 10 times to get that 100, right? But if it's only calling for 2 milliliters, this is a much more precise instrument to get that number. So just keep that in mind when you're doing measurements, because we're going to start doing measurements and we're going to start doing calculations with those measurements when we get into the physics stuff. And that is going to be important that you keep the precision of the instrument, you're estimating beyond 1 point, and making sure you have no naked numbers. Hope this helps.